Okay. Okay, so um okay. So I think I'm just gonna wait a bit until people start showing up to watch. So yeah. Ito, or at least I'll wait until 8:10, which is in like a minute. Okay. Okay, so it is officially 8:10, at least according to my clock. So I'm just gonna start the presentation. Okay, so this is for chemistry lab or chem lab, and I'm Emily. Hi. Okay, so the description. This event is a lab event similar to forensics if you watch that video, which means that it's half lab and half written. And like usually one partner will do the lab part and one partner will do the written part. Um in my experience, usually what works out best is if one partner starts on all the problems and one person starts on the lab, and if the lab person finishes early, then they can help the written person because there's usually like a lot of questions, and there's like a rotation of topics because chemistry is really broad, and if they tested you on absolutely everything, it would be a ginormous test, and no one would want to do this event. So the two topics this year are thermodynamics and gas laws. And a word of advice to anyone who's thinking about doing chem lab this year, how the rotation system works is that gas laws was also a topic last year, so keep in mind that you'll also be competing, if you make it onto the team, against other people who already have like a year or a season of experience doing these types of problems. So I advise you to focus on gas laws especially. Okay, so parameters, you get 5 pages of notes, which is limited space, but you have to work with it. Safety, because there is a lab component, so you have to be aware of that. Obviously, since there's a lab, you need to know lab skills and be able to clean up after yourselves. And you should have at least a basic knowledge on all parts of chemistry, because even though the main topics are thermodynamics and gas laws, that doesn't mean they aren't allowed to ask you questions on other topics. And also in chemistry, to even like understand thermodynamics and gas laws, you need a very basic knowledge of chemistry in general, and that includes like elements, writing formulas, naming, stoichiometry, all like the basic stuff. And as a note for this, if you are taking chemistry, like chem honors or AP Chem right now, or you have taken chemistry in the past, this will be much easier for you. But if you're in like freshman bio or something, it's not impossible to do, but it will definitely be harder since you're not having the extra knowledge of going to class every day. And I would say, on average, the chemistry lab, Science Olympiad tests are on average the same level as AP chemistry. It might vary a little depending on who makes the tests, but on average it's about that level. So you should try to aim for that, but chem honors level is definitely good enough. Um, and for this test, you need to have speed and accuracy. So there's a lot of questions. You want to try to finish as many of them as you can, and you should definitely try to finish the lab. But if you get everything wrong, that's not going to help. So you should practice to be fast and right. So for content this year, it's thermodynamics and gas laws, as I said before. So thermodynamics, this includes exothermic and endothermic reactions. As you can see in this picture, it's just a simple picture of an endothermic reaction, I'm sorry. So you should be able to answer like basic concept questions, stuff about like heat and work and those kinds of things. You should have the formulas like either memorized or on your note sheet, because formulas like in this event basically are a really huge deal. So if you don't know the formula for something, you're basically screwed. You also need to know the heat of various things, such as heat of combustion, heat of formation, heat of reaction, stuff like that. And you should also know basic like processes, such as like how calorimetry works, and Gibbs free energy, entropy, and Hess's law are only state or national level, I'm not sure which, but basically it's not going to be tested on the regional test. But again, you never know depending on who makes the test, so you should still be prepared for those as well. And so thermodynamics, um, it's kind of like a broad category, but if you search it up, it will probably give you a pretty good overview of what it includes, and includes these things I listed here, as well as like specific heat, like changing from different phases to others, and basically like the heat and partial reactions that are involved in chemical reactions. So gas laws, this was also a topic last year. So gas laws, formulas again are really huge. Concepts such as properties of ideal gas, like why a certain property like happens, or why something happens, is important because they might ask you that. And I would advise you to memorize as many of the formulas as you can, especially the simpler ones, such as like Dalton's law, Boyle's law, Gay-Lussac, Charles' law. Like those are really easy to memorize. So like save the space on your note sheet for more important things, and just like keep those in your brain. And so also they will have a lab, and the lab varies on what you have to do. So for this one, I just included a simple diagram of one example lab that they gave us last year, which was collecting hydrogen gas over water from a reaction of zinc and hydrochloric acid, I believe. So I'll just explain this setup really quickly because it's a pretty simple lab. You drop solid zinc or any like transition metal basically in hydrochloric acid with a stopper and a tube for the hydrogen gas to go up, and you flip a graduated cylinder um, over water, and you flip it over water, and basically the hydrogen gas will get trapped, and they'll usually ask you to collect data, perform some calculations such as like finding the pressure or number of moles of the gas and things like that. So you should be able to be familiar with the process. And also for labs, it's kind of difficult because you don't know what they're going to ask you. It might be something that you've done before, it might be something that you know how to do, and it might be something like completely brand new that you have no idea how to do it. And also the directions they give you can be vague to non-existent to very detailed. So I would recommend you to search up basic labs that relate to thermodynamics and gas laws, because if they don't give you very specific directions, or they don't give you directions and you don't know how to do the lab, you're basically screwed. And if you don't know how to do the lab but they give you like a page of instructions, that takes reading time, which takes away from actual experimental time, which takes away from like testing time, and they'll like leave you with not much time in general to cover. And also, I don't think I said this in the beginning of the video, but I'll be checking any comments that people leave at the end, so feel free to post something, and if I don't get to it, feel free to email me. Okay, yeah. So that would be what I would advise. And you might want to reserve part of your notes for like writing down like simple steps for labs so that you don't forget, or if they give you something you don't know. So like in this example, I actually did this in school, so I knew what to do, even though the direction, so I could basically skip what little directions they gave me and just do the lab. So it was good. Okay, so sample problems. Every test format is different, obviously, because they're all written by different people. So like, for example, last year at regionals, they were made by people from Stanford, which was very interesting because the questions were all extremely complicated. And oh, something that I forgot to mention, on the rules manual, they give you an overview of what you should know, and it says you should be able to notice symbols and charges for the following ions, and they give you a list. Those you definitely should know, but that doesn't mean that's like all you need to know. You should like put maybe like a list or chart of other more rare ones, especially if they give you some random ion and you don't know what it is. You won't be able to do the problem at all, which happened last year. Yeah, naming, formula writing, stoichiometry are very important. Okay, so the questions will either be information based or lab based. So for information based, obviously they'll just give you problems. Usually there'll be like free response, meaning you have to do the work. Sometimes they'll give you multiple choice, but yeah. And there's also dry lab, which is they give you a scenario, and well, they give you a lab setup that they've written up, and they've done all the like lab part for you. So they just give you all the data, and they ask you questions and ask you to do calculations given that data. So that's a dry lab, and usually the person who does the written stuff tries to do this. And there's also the wet lab, which is where you actually have to do experiments and do stuff, and hence wet. So for screening, you will not have to do a wet lab because that would be a lot of materials. But hint, hint, there is dry lab stuff because I want you guys to be able to like be given information in a data table and figure out like the questions I'm asking. So here I have a very simple sample problem that I'll go over. Okay, so it says a sample of dry gas weighing 3.1134 grams is found to occupy this many liters at 22 degrees Celsius and 740 millimeters mercury. So how many moles of the gas are present? So for this problem, you'll use the ideal gas law, which is PV equals nRT. So they give you pressure in millimeters mercury, but you will have to convert that to ATM using a conversion factor. So after you do that, you literally just plug everything in. R is a constant, which is 0.0821, I believe, liters ATM over moles Kelvin. And you just solve for N, which is the number of moles. So this is like really seriously on the easier side, but this is just like an example problem of gases to get you into things. Okay, so sorry, that is my phone. So some resources that I find helpful, definitely the Science Olympiad wiki site, because that is basically where people post all their troubles for events and people give answers, so that's good. And the official Science Olympiad website usually has good like guidelines and parameters and basic information to look at. Google is amazing. If you ever need practice problems, just go to Google, type in gas laws practice problems or thermodynamics practice problems, and it'll give you like thousands of problems. Obviously not all of them are going to be like Science Olympiad level, like the one that I just showed you, that's like really simple. But if you can, finding like AP, like questions from the past AP exams on these topics is good practice, because that will most closely represent the types of problems that you'll be given. Okay, and Google is also really helpful. Like if you don't understand a concept or you want to see people working through a specific type of problem, then go to YouTube, search it up. There's probably like bunches of people out there because lots of people want help on chemistry. So that's very helpful. And there is a textbook that I think is pretty good. It's Chemistry, the Central Science by Brown, LeMay, and Boston. I have the ninth edition. Um, it's like, it has a blue cover with like a pyramid shape on the front. I don't know if that helps. Um, Obviously this is not like required. You don't have to buy this, go out and buy this, but it's just something that I find helpful because it has sections on all of the topics in thermodynamics and gas laws. There's like a couple practice problems in there, and I just think it's a pretty helpful test. So, um, we're about at the halfway point, I think. So I'll go check for questions, and if there aren't any, I will come back and talk more in depth about stuff. Okay, and there was no one here or no comment. So is how many times you want because it's not gonna get taken down. Okay, let's see. What else is there that is helpful? Um, Parameters. Oh, another thing that's helpful for studying is practice tests because those are very good for seeing how well you can time manage because that's very important in this. Um, Testing like your knowledge of questions. And as for the style of questions, it usually requires you to like apply like not just one concept. Like they won't just ask you about a concept using like just ideal gas law or just Dalton's law or just Hess's law or whatever. They'll make a question that combines multiple different concepts. And another thing that is important to make sure of when you're practicing for chem lab is to be able to know what equations you need for what types of problems. So, um, like when you're given a problem, you can't sit there for like a minute or something just trying to figure out like how to tackle it and what um formulas to use. Usually you're able to figure that out relatively quickly, so you have more time to actually work on the problems because um I'm just gonna tell you right now, like the vast majority of all the questions that they give you will require like calculations and work, and you'll have to show that you can't just like magically come up with an answer. So that's important. um let's see. Okay, so for content I'll go a bit more in depth. So um if there's any like lab things, they'll give you equipment and they'll give you the periodic table by oh, but I would suggest like printing or like putting a small one on your notes sheet just so that you don't have to keep on sharing one with your partner. And for notes sheets, I would recommend like lots of diagrams and like maybe some like example problems or something to make sure that you know like how to use each equation, because that's another common problem. Like you have all these formulas, but like if you don't know how to actually use them in applying a problem, that's very difficult. So when studying, like you see all these topics like heat of combustion, heat of formation, gas laws, Boyle's law, all those things. Like I would search up like questions for each of those subtopics first just so that you can know how to tackle them and then try more complex ones. Okay, so for gases, it says Avogadro's law, Boyle's law, Charles' law, Dalton's law, Gay-Lussac's law. I would include the ideal gas law and the combined gas law, because honestly, you don't really need Boyle, Charles, and Gay-Lussac's laws as long as you know the combined gas law, Graham's law, and the ideal gas law. And also for resources, if you're like taking chemistry right now, if you ask your teachers for resources, they would probably be happy to help you. And especially if you're in chem honors, or like if you're taking chem honors right now, you're not gonna talk about gas laws or thermodynamics until like second semester, so you won't be able to just like learn them in school. I believe right now you're learning like the basics, like naming, stoichiometry, formulas, reaction predictions, all that stuff. So that's good because you're getting the basics down. But if you want to study for these, you're gonna have to do them on your own. Yeah. So density of gases, partial pressures of gases, molar mass, rates of relative diffusion, all of these concepts have formulas. So I would advise you to go search them up and figure out how to use them. For thermodynamics, let's see. Endothermic and exothermic processes, those are really basic units of heat measurement. So you should know like joules, calories, and make sure to know all the conversion factors, because for gases there's a lot of different units for pressure, and you're gonna have to know all of them because they're gonna give you problems and they're gonna be in like totally random like units. So you should definitely know conversion factors. Heat capacity, calorimetry, enthalpy change, thermochemical equations, heat of fusion and solidification. Okay, whatever is for heat of fusion and solidification, if something goes from ice to liquid, you have to use both, because there are different equations for fusion and solidification at like liquid stage, solid stage, gas stage. So you're gonna have to use multiple ones, so don't fall into the trap of just using one equation, because that is not right. Heat of reaction, standard heat of formation and heat of reaction, and associated calculations. So this is very awkward. Okay, so let's see, I'll go a bit more in depth. So exo and endothermic. Exothermic means it's releasing heat or energy into the environment, which is why in this picture you see here, the part that's labeled C is much higher than the portion labeled A and B. And exothermic has a this is endothermic. So endothermic is gaining heat, which is why the C is higher than the A and B. And endothermic means it's taking in heat or energy from the surroundings, which is why it is labeled heat input, if you can see that. And the little like hump before C is the activation energy, which is basically how much energy you have to input to like get the reaction starting. Heats of various things. You will just have to search those up. Heats, it's essentially just a lot of equations that you just have to know how to do. For thermodynamics, you will need to know a lot of like specific values of things for like a bunch of compounds, which I believe they will most likely give you on the test, because if you don't, your note sheets are basically going to be completely filled up by random constants. But you should at least know the ones for water, because it's pretty common. But I would assume that they would give you the other ones, so you shouldn't worry too much. So about screening, hint, hint. Again, as I said earlier, just because the main topics are thermodynamics and gas laws doesn't mean they won't test you on other things. You can use your 5 pages of notes. I would advise you to put diagrams, because those are like a lot easier to look at and understand than like paragraphs, words. Make sure to bring a calculator, because chemistry is essentially impossible to do without a calculator. And yeah, okay, let's see, I will go check to see if there's any more questions again, and there are none. Okay, so I think this concludes the presentation. The chemistry book that I showed, the Central Science 9th edition, that is also the one I was referencing in the forensics video cast. So if you know anyone that was watching that one and is interested, please let them know, because I did not have the book at the moment, so I could not tell them exactly what it was called or who it was by. But yeah, I think that concludes it. If you have any questions or want any possible additional resources, feel free to email me. My email should be somewhere in the giant flood of emails that you've probably been getting. But yeah, that's it. Have fun studying, and good luck on screening. Don't die. Woo. Okay.